Good day to everyone. Today we are going to discuss our first topic for the subject EnggPhys or Physics for Engineers. So in this topic we are going to discuss all about vectors, and with that let us just have a simple or a brief introduction of what is physics. Since our subject is physics and vectors is studied under this. So basically, or probably you have already known what is physics, and physics is simply defined as a science that would deal with nature and matter. And with this, when we study nature or matter itself, what we do study here is its motion and its interactions, or the interactions of matter and its structure, or the interaction of those inside their matter, its structure. So when we talk about interaction, this would now relate to our forces, energy, and the like. And since we are talking about nature and matter, physics now is distinguished as a fundamental science. Since we are talking about the broad topic of nature, almost all sciences now are based or is related to physics. Okay? And aside from being a fundamental science, physics now is also distinguished as a foundation of engineering. Why? Because in engineering, there are many topics in which, or yes, many topics in engineering that is covered by physics. So what are this? So we have your mechanics, your optics, the study of light. We have your electrical studies. We have your electronics, nuclear engineering, and so on. So basically, being a civil engineer, so as a civil engineering students, civil engineer will be focusing on mechanics, which is the study of forces and its interactions. So if you're an electrical engineer, an electrical engineering students, then aside from having knowledge on mechanics, we also need to know the foundations of electrical currents, which is a part of physics. Okay? And since we have said that physics is a science, we now apply a measurements, or we always measure what we study in physics. And these measurements now that we do in physics would always define the physical characteristics of the matter or of the object. Okay? And these physical characteristics now that are defined through measurements are what we call your physical quantities. So physical quantities, these are now measurements that are used to define your physical characteristics. So when we talk about physical characteristics, this would now include our observable characteristics of an object. So example, we have the size, the length. So how big is it? How long is it? How small? Okay, how heavy it is. So when we define those, we use your physical quantities. So since we are talking now about physical quantities, we can divide or classify your physical quantities into two. So that is now based on the units that we use in defining them. The first one is what we call our fundamental quantities, and we have your derived quantities. Okay. So when we talk about fundamental quantities, these are now physical quantities that are independent of their own. When we say independent, there are no other terms that could define that quantity or that fundamental quality. So what are these fundamental quantities? We have 7. So what are those 7 fundamental or basic quantities? We have your mass, we have your length, we have your time, we have your electric current, amount of substance, we have the temperature, and your luminous intensities. So these 7 now cannot be defined by any terms except their equivalent fundamental quantities such as your meters, your seconds, and your time. Unlike for the derived quantity from the term itself, it is derived now from other terms. And saan natin siya dinederive? We derive it from our fundamental quantities. So basically, derived quantities now is derived or is a combination of the different fundamental quantities. So what are examples of our derived quantities? We have your speed, which is a combination of meters per second. So it's a combination of length and time. So as our force. So the unit for force, or we define force in terms of newtons. So it's a single term, but newtons is basically equivalent to kilogram meter per second squared. So it's now a combination of 3 fundamental quantities. What is that? We have your mass, we have your length, and we have the time. So that's the difference between fundamental and derived quantities. So aside from classifying our physical quantities based on the terms we use to define them, we also have a classification of physical quantities based on their definition, which is, we have now what we call your scalar quantities and our vector quantities. So when we talk about scalar quantities, these are now quantities that would only have a magnitude but no directions. While for vectors, these are now physical quantities, or these are quantities used to define our characteristics all together with its direction. Okay? So, as I have said, for our physical quantities, for scalar quantities, we have the magnitude. So when we talk about the magnitude, that would simply be the value or the amount and your unit. So when I say 3 meters, that's a scalar quantity. It has a value 3 and it has a unit meters. But for vector quantities, they will have now a magnitude and a direction. Okay, so when I say 3 meters down, so it has a value 3, it has a unit meters, it's downwards, so it has a direction. So that's the difference, that's the simple difference between scalar and vector. So scalar, value and unit lang. Vector, there's already a direction. Okay? So for our representation of a vector, normally we represent it by an arrow. And for this, the length now of the arrow will simply represent our magnitude. Okay? And then, kung saan siya nakaturo, yung arrowhead, that is now where the direction is also pointing. Then, the parts of our arrow would now be our tail. Okay? And then we have your head, or we also call this as the tip. So, head, tails, or tip, tails. So, that's the same. Okay? So, for our direction or notation for the direction of vectors, we have several ways of writing or of defining the direction of vectors. This will now include the simple up, down, left, or right. Okay? So, another way is by the axial directions. So, mathematical na siya. Axial. So, we have your positive x, negative x, positive y, negative y. So, we have your Cartesian plane. So, kung 3D naman siya, the directions would now include your positive and negative z axis. And then, we have your geographical directions, which is more commonly used for 2 dimensions. So we have your north, east, west, and south. Okay? So for our directions, so we have here your west, so it's pointing to the left. We have your north going up, east is moving to the right, and we have going down is your south. And when in terms of your actual direction, so in your Cartesian plane, north now is equivalent to your positive y. We have your east as your positive x, west is your negative x, and south is your negative y. Okay? Okay, so to understand further our notation for the directions, or how do we draw our directions for vectors, let's have an example. So let's say we have the direction indicated as 40 degrees north of east. So how are we going to represent this direction? So firstly, we have your Cartesian plane representing our east-west, or your x-axis, and your north-south, or the y-axis. So from here, basically we need to measure 40 degrees. But where are we going to measure? Are we going to measure from the north or from the east? So in this case, it says of east. It means we have to measure it from the east. So 40 degrees from the east going to north. This is now our direction. Okay, so this is now the line of action, or the line of direction. So this simply means it's 40 degrees north of east, or from east going to north. Or this direction now could also be written as east 40 degrees north. So east 40 degrees north. Or this could also be written using its complementary. So we have now 50 degrees. So where did I measure 50 degrees? I started it from the north. So this could also be written as 50 degrees east of north. Okay? So kung saan yung off, doon nag-start. Okay? Or again, this can be written as north. So north 50 degrees east. Okay? So pag may off, doon nag-umpisa. Pag walang off, kung ano yung una, doon tayo mag-uumpisa ng measurement. So aside from that, using north of east, or this notation, we could also write our direction in terms of a single basis, which is our 0 degrees, or the east. Or that is now 50 degrees, or that is now 40 degrees from the east. Okay? And it's measured counterclockwise, since our measurement of angles is always counterclockwise. So 0, 50 degrees. Okay? So if it's stated 50 degrees, it means it's from the east, unless stated in the problem. Okay? Another example, let's say we have 65 degrees west of south. So anong ibig sabihin nun? So of south, meaning I'll be starting measuring 65 degrees from the south. So it will now be 65 degrees going to west. So this is now our line of action for this direction. Or if we're going to rewrite it, equivalent directions would include south 65 degrees west. Okay? Or it's complementary. We have 25 degrees. So that will now be 25 degrees south of west. And we have west 25 south. Or from the east, that will now be 90, 180 plus 25. So that's 205 degrees. Okay, that's for our notation, how we draw or measure later on your directions. Okay, so now we have learned how to draw and represent our vectors. Another important thing to learn in vectors is to identify the difference between collinear, coplanar, and concurrent. So when we say collinear, or the vectors are collinear, it means that they are lying on the same line. Okay, so they are parallel as much as possible. So to understand this, let's see, we have here vector A, vector B, C, vector D, vector E, F, and G. Okay, so which of these vectors now are considered collinear? So when we say collinear, so same line, meaning parallel sila. So we have now vector A. So what are the vectors collinear to vector A? That will now be vector C and F. They are all along the horizontal. Okay? And then we have vector G. So which is collinear to vector G? That would now be vector D. So they are both along the vertical. Then next, for B, it is now collinear with vector E. So as you can see, it's not necessary that the vectors should be pointing on the same direction in order for us to say that is collinear. As long as it's lying on the same line, no matter what the direction is, they are considered collinear. Okay? So next one, we have our coplanar vectors. So when we say coplanar, so from the word plane and co, meaning they are now lying on the same plane. So when we talk about plane, we have your xy plane, your xz plane, and your yz plane. Okay? So, para yan pag kunwari, sa wall, may mga picture frames tayo, may clock na nakasabit sa wall ninyo. If they are lying or they are hung on the same wall, those picture frames are coplanar. Okay? Pero kunwari, yung isang picture frame nyo, nasa kaliwa, yung isang picture frame ninyo, nandun sa may kabilang side, then it is non-coplanar. Okay? So, they are on the same plane or nasa same wall sila dapat. Okay? So, to understand this, let's have our planes. So we have here your x to y plane, we have your yz plane, and we have your zx or xz plane. So let's have vector A, vector B, vector C, vector D, vector E. So which of the following vectors now are coplanar? So we also have here vector F. So which of them are coplanar? So we have AB, they are both lying on plane x, y. And then we have vector CD, they are lying on plane YZ. And we have vector EF lying on plane XZ. Okay? So, basically, mas malalaman natin tong or ma-identify natin kung coplanar sila depending on our direction. So, for example, we have northeast, east-north. So, they are coplanar. Okay, nasa XY plane lang sila. So next we have concurrent vectors. So when we say vectors are concurrent, it would mean that they would lie on, so current point or current position, or they will be lying on the same point, or they would pass through a common point. Okay? So to understand this, let's have these examples. So we have several vectors here. So let's identify which of them are concurrent. So basically, we'll have vectors A, B, and E, which are passing at a common point, which is the point of origin. Okay, another noticeable set of vectors that are concurrent would be your vector C and D. So they are concurrent at this point. Okay. Next, do we still have any other concurrent vectors in the diagram? So there's still remaining set of vectors. So we have now GB. So why is vectors G and B concurrent? They are not naman intersecting. So if I will now extend vector G, or the line of action of vector G, until it reaches point 1, we can see that we will be intersecting at this point. So meaning, vectors B and vector G are concurrent at point 1, or the point of concurrence is point 1. Okay? So, it means, hindi sila nag-intersect, they will now not be considered as concurrent. So, we always look at the extensions of our vectors, especially for forces. So, here, you can see the extension. So, if I extend this, they are passing at a common point. So, another one, we have, obviously, we have points or vector E and F, which is now concurrent at this point. So this is point 2. Okay. So next one, we'll have vector A and D. So same as for GB, if I extend now vector D at this, towards this direction. Okay. So we can see that they are concurrent at point 3. Okay. So if I'm going to do the same thing at C, and it will now intersect vector F. So are they now concurrent? No, they are not concurrent, as vector C is on your YZ plane and F is in your XZ plane. Mukha lang siyang nag-intersect, pero pag titignan natin siya spatially, hindi sila nag-intersect. Okay? So, however, your vector C and vector F could be concurrent if now our vector F will instead be positioned at point 4. Okay? So, kung nandito na siya. So, kung dito nakalagay siya, so nasa plane XZ pa rin siya, pero tatama siya dito sa point 4, in which C will also tatama, then FC will become concurrent. But in this case, they will not be concurrent. Okay, so that's it for Module 1 vectors. So I hope you have learned or have additional knowledge based on your readings of Module 1. So if the examples are kulang, then there are more examples in the module. You can review them. Okay, so the activities for Module 1 will be uploaded in the classroom. Just wait for it. Okay, again, thank you for listening.